Welcome to Module 5 of the Sanitation Safety Planning Methodology. My name is Sophie Boisson and I will be your guide in this module called Monitor Control Measures and Verify Performance. In this module, we will answer the question: is the sanitation system operating as intended and is it effective? In Module 5, we will define and implement operational monitoring, we will verify the system performance, and we will audit the system. In the end, we will produce one of the key products of SSP, which is an operational monitoring plan. In the previous modules, we saw that to reduce a health risk, control measures need to be in place. There are two types of monitoring: operational monitoring, which aims to check if the control measure is working, whereas verification monitoring aims to check the overall impact of those control measures. The purpose of step 5.1 is to select monitoring points and parameters to give a simple and rapid feedback on whether control measures are working as planned, so that if they're not, we can act quickly to take corrective action. Operational monitoring collects and uses simple observation and measures such as flow rate to check on retention times, temperature of composting, observation of on-farm practices, and so on. It uses sampling and testing such as chemical oxygen demand, biochemical oxygen demands, and suspended solids. Practical consideration dictate that only a limited number of indicators can be monitored. However, we need to ensure that they do monitor the entire sanitation service chain. At the toilet step, possible monitoring parameters are the quality of the construction, the existence of hand-washing facilities, the cleanliness of facilities. These may be collected via inspections of dwellings and buildings, which may be done routinely in periodic or special surveys or in national censuses. At the containment and storage and treatment step, possible parameters are the state of the cover slab, whether it's cracked or damaged, any visible or reported overflow, resting time of dry sanitation technologies. These data may also be collected by inspection of dwellings and buildings. In the reading materials, you will find sanitary inspection forms for sanitation systems. These are short standardized observation checklists to identify risk factors at or near sanitation facilities. Sanitary inspection may be used by community representatives, government officers such as environmental health inspectors, or field officers from national and international organizations. At the conveyance step, possible monitoring parameters are use of personal protective equipment by sanitation workers, number of licensed operators, use of the predefined roads, extent of leakage in sewers, cleanliness of sewers. Data on emptying and transport for on-site facilities and on leakage or overflow of untreated sewage may be collected from customers, formal and informal operators, and where relevant, licensing authorities or regulatory bodies. At the treatment step, typical monitoring parameters are the flow rate, retention times, chemical oxygen demand, biochemical oxygen demand and suspended solids, or composting temperatures. Data on the effectiveness of sludge and sewage treatment may be collected from operators and verified by occasional sampling and independent laboratory analysis. At the end use or disposal step, monitoring parameters include visual inspection of the application or irrigation process, actual versus planned duration of his withholding periods, frequency with which farmers are wearing personal protective equipment. Data may be collected via inspection of nearby farms with routine or periodic surveys. Monitoring all control measures is often not practical, so the most critical point, based on the control of the highest risks, should be selected. Critical limits are usually numerical limits based on the parameter measurement. In some cases, qualitative limits are appropriate. This is a typical recording format which includes the following aspects. Parameter, what is being monitored, what is the limit, the methods of monitoring, means how it is done, where it is monitored, who will monitor, the frequency of monitoring, and action to be undertaken when the critical limit is exceeded. Now, let's talk about verification of performance. Step 5.2 involves verifying whether the system is performing as intended. Verification monitoring may be done by the SSP team or an external authority as part of surveillance. Verification data may include for toilets, use of toilet facilities, for containment, storage and treatment, pathogen concentration in groundwater, conveyance, amount of fecal sludge transported to the treatment site, treatment, microbial testing of effluents, for example E. coli and Hellmann's eggs, and end-use disposal, microbial testing such as E. coli and Hellmann's eggs of crops, fish products and waters at exposure points. Step 5.3 is about auditing the system. Provides additional independent evidence of the quality and effectiveness of SSP implementation. Audits may be a regulatory requirement for risk assessment and management approaches. It may be done by internal or by regulatory or independent auditors. Suitably skilled and experienced personnel for auditing will need to be identified. Great! So we have now completed Module 5 of the SSP methodology. You have learned how to define and implement operational monitoring, verify the system performance, audit the system. In the WHO 2018 guidelines, you can learn more about the role of environmental health authorities in monitoring. More information can be found in Module 5 of your SSP manual. In the next and final module, you will learn about developing supporting programs and reviewing plans. Thanks for watching and happy SSP!